So for question 32, we have to solve for x, and this is pretty easy. All we need to do is take the square root of both sides to get to the x. Square root of x squared is x, and square root of 29, there are no doubles in 29, so we just have to leave square root of 29. Don't forget the plus and the minus part. That leaves us with D for our answer for that one. All right, 32, we have to solve for r. Prior to solving for r, we need to add 3 to both sides to isolate the r squared. So that gives us r squared equals -7. We have to take the square root of both sides to get to r. And that leaves us with r equals plus and minus the square root of -7. Well, 7 has no doubles, so we leave it as the square root of 7, but you can take the square root of a negative. The square root of a negative is I. That leaves us with plus and minus I root 7. And that means A is our answer for that one. Okay, so for number 34, I see I have k squared minus 3k equals 4. And what I want to do is I want to pull all the terms to one side. So I'm going to subtract 4 to both sides. And that gives me k squared minus 3k minus 4 equals 0. This is a quadratic that we can solve using the quadratic formula, or we can factor. I see that we can factor. There are two numbers that multiply to make up 4, and difference between them is a 3. 4 times 1 is 4, and a minus 4 plus 1 gives us a minus 3. So we have to figure out the values of k by setting our factors equal to 0 and solving. So k plus 1 equals 0. We subtract 1 to both sides. We get k equals a minus 1. And k minus 4 equals 0. We're going to add 4 to both sides. And, oops, we end up with k equals 4, which means that our answer is B. All right, so for our next one, we have to solve for x. And I'm going to everything to one side to start by subtracting 7x to both sides. And that gives us 3x squared minus 7x plus 4 equals 0. And I can solve this using the quadratic formula, or I can try and factor. And I'm going to try and factor at this point here. I want to see if I can do so. So 3x squared is made up of 3x times x, and 4 is made up of 2 times 2, or 4 times 1. So that's just 2 and a 2, so let's see if that will work out. So that the outer 2 and the inner 2 have to combine to give me the middle term there. So 6x gives me the outer 2, and 2x gives me the inner 2. There's no way I can get a minus 7x out of that. That's not working. Oops. So I'm going to try and see if I can factor with a 4 and a 1. So I'm going to put a 4 and a 1 here. And I'll put the 4 here and the 1 here. And I get a 7 out of that. The outer 2 gives me a 3x, and the inner 2 gives me a 4x. And I can get a negative 7x out of that. Both of these are negative. That means that I need a negative 4 and a negative 1. So from here, if I set my factors equal to 0 and solve, I'm going to end up with D for my answer on that one. Okay, so for 36, we have to solve for k, and I'm going to start off by adding 9 to both sides so that we have all the terms of the quadratic on one side. And we have k squared plus 10k plus 9 equals 0. And I'm trying to think of two numbers that will multiply to give me 9 and add up to give me a 10. That's a 9 times a 1. 9 times 1 is 9, and add them up, you get a 10. If we set our factors equal to 0 and solve, We end up with B for our answer on that one. Okay, so for 37, we have to start off by pulling all terms to one side so that we can be quadratic. And I'm going to subtract 19 and add 3 to both sides. That gives me 2p squared plus p minus 19. And at this point here, I'm not going to factor. I'm going to use the quadratic formula because I can see that my answers here have square roots, which means I'm going to need to use the quadratic formula with the A, B, and the C. So let's plug all those in. I'm going to put it on pause and show you what I get. Okay, so this is after we plugged in A, B, and C. And now we have minus 1 plus and minus the square root of, we have 1 squared, which is 1, and negative 4 times 2 times negative 19. That is 152. So 1 plus 152 gives us 153. Square root of 153 and then over 4. So I need to figure out how to simplify this at this point here. But just a little investigation. I can see I have a negative 1 here. And so B is not one of my answers. Also, I would mean that I'm taking the square root of a negative, which means B is not one of our answers. I can choose between A and C right now and have a 50-50 shot. Let's see how we can simplify 153. 153 is divisible by 3, and it's 3 times 51, and 51 is 3 times 17. So remember that with square roots, we're looking for doubles. And so I can pull out a 3, and that leaves me with a minus 1 plus and minus 3 root 17 over 4. And which one is it? It has to be C then for our final answer. Okay, so for our next question, it says to find the discriminant, then state the number and type of solutions. So the way I introduced this type of problem to you guys is I told you to tell me how many x-intercepts there are. And we can do that by looking underneath the square root, which is known as the discriminant. So let's start off by just using our quadratic formula and figuring out what it means as far as our x-intercepts are concerned. So we have to identify the A and the B and the C, which means we have A is minus 4, B is minus 7, and C is minus 5. Let's plug it in to the formula and see what happens. Okay, so plugging everything in, x equals, and let's simplify what we have. A negative times a negative, positive, x and minus, the square root of, we have negative 7 squared, which is 49, and then negative times negative times negative is going to give me a negative. Let's see, we have a 20 times 4, 20 times 4 is equal to 80. And this is all over negative 8. So from here we have 7 plus and minus square root of 49 minus 80 is equal to a negative 31. This is all over minus 8. And what our answer forces us to do is look underneath the root. That's known as the discriminant, and that tells us how many answers there are. Because we have a negative underneath the root, that means that there's no real x-intercepts there. And so we refer that to as an imaginary solution because we don't actually go through the x-axis. It's imaginary. You can think of the square root of a negative as I, and so you can kind of relate that I to an imaginary solution. Okay. So for our last two questions, we have to sketch the graph of the function. And we have a couple of parabolas we need to identify. Question 39 is a parabola that's in vertex form. We can identify the vertex by taking the opposite of the value inside the parentheses here, the minus 2, and we are left with a plus 1. This is the vertex. So I'm looking for a vertex where we're at negative 2 plus 1. That's not 1. That's not 1 either. It looks like it's going to be D because this one actually has a vertex of negative 2 plus 1. And also, we should have a parabola that's faced up because if we were to expand this all out, we would end up with an A value that's positive, which means that we have a parabola that's faced up. Remember that you can always plug in values. You can always create kind of a chart and plug in X and see what you get for Y. And that should be a point on your graph. And in this case, when I plug in a negative 2, I end up with 1 here. And that is a point on the graph right here. So let's look at our last question. So for our last question, we have to identify this particular parabola. Our A value is positive, which tells me we have a graph that's automatically eliminate A. That's one of the answers. From here, I know that my y-intercept is when the x is 0. Put x is 0 and with 8 for my y-intercept. Now another thing I want to know is what's the very middle of my graph? What's my line of symmetry? And we can use negative b divided by 2a to identify the very middle. I plug in negative 4. I have a minus minus over 2 times 1. And that gives me 4 over 2, which is 2. So the very middle of my graph should be right at 2, and I should have a y-intercept at 8. This has a y-intercept at 5, but that's not right. This one here, and actually 0, y is 8. That's a possibility. And also, I see here that my line of symmetry is at 2. We don't have that going on with C. C has to be our answer.